Let's look at number 1 from Brian Passwater's Unit 3 MCQ review. All right, it says the figure shows 2 full cycles of a periodic function f, which of the following statements is true. All right, well, let's look and see where these cycles, I can see, it tells me there's 2. I can see where the cycle starts and where it stops, and I can see the pattern. And so I can see that 1, 2, 3, 4, 5. So a cycle is 5. So I know f is going to have a cycle, or a period length, I should say, of 5. So let's look here. Period of 5, 10. Okay, it's so important that we're able to cancel out options that are not true. Now, also, let's look at this pattern here. I know I want to figure out what is the output when the input is 31. So I want to know when I go to 31 horizontally, where will I land? So we're going to go in patterns of 5 here. So let's just do this as simple as possible. We could write out an expression that represents this, or we could simply go, okay, I'm starting at 1, and then I go to 6, and I'm going to continue to add this 5. Notice adding 5 brings me to 11. Adding 5 more is 16. You're at 21. Adding 5 more, 26, and 31. And you're asking me, why am I doing that? Because at the very start, so starting this cycle, at the start of every single cycle, we have the same output, an output value of 1. The correct answer is A. Now, if that seemed confusing to you, what if they did something like this? What if they said f of 32? Okay, I can still see that the start of the cycle, each one of these is the start of this 5-part cycle, and the start will always be a 1. But 32, I know this isn't the problem, but I just want to give you another example here. 32 would be the second number because the first one. So what is the second number? We can line it up. 32 would be 3. And if we said f of 33, we can now see f of 33 would be, there's our first, our second, and our third, right? And so our third, 1, 2, 3, it would also be 3. Hopefully you're catching on.